Hello everyone. In today's video, we will demonstrate how to use our ODOT DU03L PLC under the IEC 61499 standard to use the PROFINET Master function. The hardware used in this video includes an ODOT DU03L PLC, a SAN 8032 PROFINET slave device, and a CT5321 Modbus RTU master or slave module. Here we also have a USB to RS485 protocol converter for the PC. Our programming software uses a BS architecture. It does not require installation on the computer. You only need to open a browser and enter the server IP address. After entering, select the IEC 61499 standard. Choose to create a project. Enter the project name. Click Save. After entering the project, first import our device description files. Select Device Repository. Select Import. Device description files can be downloaded from our official website or by contacting us. Click to enter file selection. First, import our PLC. After the import is successful, continue to import our CN 8032 PROFINET adapter module. Select it. Continue importing. Both have been imported successfully. Next, we can begin our device configuration. Add device. Select our PLC. Then enter the newly created project. In the project tree on the left, select System Configuration. Choose Add Device. Select our DU03L PLC. Click Save. Click the PLC again. Configure the IP address. The IP address of this unit is 10.10.10.100. The port number is 61500. Select Save. Test whether the login is successful. Here you can see that the login is successful. Right-click the PLC again. Select Add Communication Protocol. In addition to the PROFINET Master, our PLC also supports EtherCAT Master and also supports Modbus TCP, Modbus RTU, MQTT, and other protocols. Here we select PROFINET. Click PROFINET to perform device scanning. It will scan the modules connected below. Click Add. Add the device to the project. Now we need to configure the submodules. Right-click the adapter. Select Add I/O module. Here I mounted a CT5321 module. Select Add. Select the CT5321 module. You can check the configuration parameters. Here we use the Modbus Master function. The baud rate is set to 9600 by default. Also check data bits and other parameters. After confirming OK, add the communication instruction. Here I choose to read the slave holding registers. No programming is required. You only need to configure the communication instructions. Select function code 03. Holding registers. Read 2 words. Click Add. Download the configuration. Download successful. Wait for the master station to start. Here you can see, on this converter, the indicator lights are flashing, indicating that communication has started. Run our slave tool. Configure the slave ID. You can see the data flow. At this point, communication is successful. The holding register data is set to automatic counting and automatically increments. At the same time, click this instruction. You can see the process data continuously changing. Communication has been successfully established. Next, return to the Resources section. Right-click to add a new resource. Select Timer Resource. Configure it briefly. We use a 10-millisecond cycle to trigger data periodically. Select the newly added resource. On the right side, select Ethernet and find a PROFINET function block. Set it to refresh data periodically. At the same time, pass the task event to the data monitoring function block. Connect the lines. IEC 61499 is event-driven, so each function block must have an event. Configure here. Enter the PROFINET device number. Switch to IEC addressing. Enter the process data address. Here I enter IB10001. Save. Deploy the project. Select All for monitoring. Here you can see the data is also being refreshed synchronously. This concludes the video demonstration. Thank you for watching.